Yeah.
Hey, YouTube, what's going on? Can you start with that one?
Yeah, like and subscribe. It's already recording.
Smash the like button.
Okay. So, functions with radicals. So, what is the definition of a horizontal asymptote, peoples?
When the limit approaches infinity.
Not just infinity.
Or negative infinity.
Negative infinity. So, the limit as x goes to positive or negative infinity of your function is your horizontal asymptote. Okay? The key part here is the positive and the negative. Now, for most functions, that doesn't matter. You're going to get the same answer. I shouldn't say most functions, a lot of functions. But if you have radicals in your function, like this, you have to look at your function approaching positive infinity and negative infinity because it can split into different directions. Okay? So let's do the limit as x goes to positive infinity first. What do you do for these things? What do you do when you're trying to find a horizontal asymptote? The proper method that he taught you.
Multiplied by the reciprocal of the highest power.
The reciprocal of the highest power. Okay, which is what?
1 over x squared.
1 over x.
It's 1 over x. Because
Oh,
this is inside the square root.
I don't like that.
So it's 1 over x.
That's toxic.
So top and bottom get multiplied by 1 over x. So okay. So what does the top become?
3 minus 2 over x.
3 minus 2 over x. Now the bottom, you have to put the 1 over x into a square root.
How do you get 3 minus 4 over x?
1 over x times 3x, the x's cancel, you get 3. 2 times 1 over x.
okay, never mind.
Okay. Now, if I'm putting 1 over x into a square root, what goes inside the square root? I.e., the square root of what is 1 over x? 1 over what, sorry? Sorry, 1 over x squared, right? So what you're doing on this bit is, I'm going to write it out. You don't have to write it out. Extend that square root. Because you need to put this 1 over x into the square root.
So it's going to be root 2 plus 1 over x squared.
So you're going to get root of 2 plus 1 over x squared. So I get the root of 2 plus 1 over x squared. Okay. X is going to infinity. So what happens to the 2 over x as x goes to infinity? It goes to 0, right? Because remember he said any constant divided by infinity is 0. So that goes to 0. He told you that, right?
Yeah.
Okay. What about the 1 over x squared? What happens to that? It goes to 0 as well. What are you left with? 3 over root 2. Correct? Make sense? That's just like everything you did before. Now we can look at it as we go to negative infinity. Okay? It's not going to be worse. It's just going to be a little different. So, same question, except now the limit.
Should we rationalize that?
Yeah, you can if you want to. Is that better? Okay. As we go to negative infinity, we're going to do the same thing. So we're going to get that's 1 over x. 2x squared plus 1. You jump it all in. I'm going to shortcut it because it looks exactly the same. you're like, what's the point of this, Baldwin?
What is the point of this, Baldwin?
Because we got the same answer, right?
How?
Why is it not the correct answer?
Because it's rooted.
Why is it not the correct answer? It's not the correct answer. Why is it not the correct answer? Okay, explain that more.
Or a negative on it.
Why?
Because it would be going the opposite way on the graph. Because if
We
you
get
not
bigger.
it this way, then not it this way.
Okay, so you're both sort of right. You're on the right track. If you look at the bottom, is the bottom ever going to be negative? It can't, because even if you put a negative number into there, you're squaring it, which is positive, right? Multiply it by 2, which is positive. Add it to 1 is positive. The bottom is always positive. Can we agree on that? Okay. Okay, let's look at the top. As
Why you always gotta stop when I'm 0 or
if you put a negative number into here, what is the top going to be? It's going to be negative, right? Negative, pick a number. Negative 10 times 3 is?
30.
Negative 30 minus 2 is?
Negative 32.
Negative 32. So you get a negative divided by an always positive, which should give you a?
Negative.
So when you go to negative infinity, it actually is negative 3 over root 2. Okay, and if you look at the graph of this, I'll punch it into Desmos here. 3x minus 2 bracket over, what is it, square root? Oh. Hey, go away. Square root 2x squared. Whoa.
Not quite.
That is,
Plus one isn't in
I know. Desmos.
You can't do it.
There we go. And if I'll put in 3 over root 2.
Whoa. What's
Sure,
your
the graph
asymptote?
already knows that it's not. Forget.
Equals y and negative 3 over root 2.
Oh, it's just showing us what we got.
I'm just showing you the asymptote. You can see, as you go in the positive direction, the graph gets closer and closer to the line 3 over root 2. They start to overlap, it looks like, because the definition, the resolution isn't very great. But if you go in the negative direction, but what is the definition of a horizontal asymptote? It describes the behavior as you go to positive or negative infinity, which is way out there. So you probably, I don't know if I think I said in grade 12, close to the origin, and close is a relative term,
Oh, then
right? You can cross it because it's describing the behavior of the function as x gets really, really, really big or really, really, really small. Okay? So when you have square roots, just be aware that you can get 2 different asymptotes depending on which way you go. Okay? So that's why we looked at, so you can do all the math, but you still have to look at the original and say, okay, what's this doing? That's always going to be positive. This one, it depends on which way you're going. So you can either have positive over positive or negative over positive. That's why you can get 2 different ways. Does that make sense? All right, that's all I wanted to say about square root asymptotes. Now we're going to do slant asymptotes. So we're going to call it slant asymptotes.
Wow.
Well, they're also called oblique asymptotes.
Wild leap.
Oblique angle, I guess? I don't know. Okay. So, He told you when you have a slant or an oblique asymptote. When do you have them?
When the power in the numerator is higher than the denominator.
By how much?
1.
Yes.
And only one, or
Yeah, we're going to talk about that. Occur, O-C-C-U-R. 2 C's, 1 R. So when it's one more, so those all have slant or oblique asymptotes. As long as the degree of the numerator is higher by 1 than the degree of the denominator, you get a slant or an oblique asymptote. Now the question is, how do you figure that out? How do you figure out what the slant or oblique asymptote is? Okay, and you have to do everybody's favorite polynomial division. Okay.
Hey, it's gonna leave.
Yeah.
Get monetized.
Okay, so let's do, which one do you want to do? Second one's too easy because it's got one.
Yeah, exactly.
Okay, plus
Okay, let's
5.
let's do the third one.
Let's just do the first one.
No, let's do the third one.
All right, we'll do the third one.
Thank you.
Okay, do you want to do synthetic or long division?
synthetic.
Which one's easier?
Synthetic.
Synthetic's usually easier. Okay, so you have to divide it. Okay, so to find the slant asymptote, sorry? Sorta. You have to rewrite the function in the form. So do you remember in grade 12, not 12, when we did polynomial division, and I said you write everything in dq plus r if you were in my class? You remember that?
Yeah.
And then I said in calculus, we write things as q plus r over d. Probably, it was in the book. It was one of those things. If you were in my class, I don't know what Mr. Steve, but probably something similar. Anyway, let's talk about q, r, and dr. Does anybody remember what q, r, and d are? Q is quotient.
Dividend.
Divider. Divisor.
I actually did get it.
R is remainder, and D is divisor. Divisor is what you're dividing by.
If it's find the slant asymptote, rewrite the function in the
Form. Sorry, thank you. There's supposed to be an M there. I got too excited. So Q is quotient. That's your answer, essentially. R is the remainder, and D is what you're dividing by. Okay, so we're going to do, let me do a straight up regular polynomial first, because you have, no, we can do that one. Let's do that one. All right, here's our x squared plus 1. This is what we're doing. We want to know the slant asymptote of this function. So we rewrite it with synthetic division, if that's what everybody wants to do. All right. What goes on the outside for synthetic division?
What makes the denominator 0?
What makes the denominator 0? We call it the a value. What is it? 1. Has everybody seen synthetic division? This is important if you've seen it. Have we all seen synthetic? Yeah? Okay. Then what do you put on the inside?
Everything minus 1 degree.
You put the coefficients, right? But what do you have to remember?
Drop the
Oh,
first one.
if it has to go down in order.
It has to go down in order, right? So there should be a 0x in there. You need a placeholder. So we're going to write 1 for the x squared. For the 0x, I put a 0, and then I put 1 for the last one.
And then you drop
Is
the
this-
first one.
Bottom stuff have to do with the x. Does the bottom x do anything in the denominator?
No, that's where I get this number here. Okay. Now, in synthetic division, I'll show you it in long division in a sec here if people like that better. You drop the 1 down. You just bring it down. Boom. And then you multiply by this one here. 1 times 1 is?
1.
And you add those two together. You're always adding in synthetic. 0 and 1 is?
1.
1 times 1 is?
1.
You get a remainder of 2. That last number is your remainder. This is your quotient. Now, we divided a quadratic, second degree polynomial, by a linear, which is just x. So what should be the degree of my quotient? It's 1. It drops by 1, right? So this is actually x plus 1. Okay? All right, and then this out here was our divisor. Divisor, divisor. That's the same thing. So we write this as q, which is x plus 1, plus the remainder, which is 2, over the divisor, which is x minus 1. Okay, so this is the same as this. X squared plus 1 is the same as x plus 1 plus 2 over x minus 1.
Would you also be able to just write 2 over 1 because it has to be the original divisor?
Has to be the original divisor.
Sorry, confusion.
Yeah.
So do like the D to both of them?
Yeah, because that comes from that is what I meant. So.
Sorry for the interruption. If Miss Anderson is in the building, please report to the office. Miss Anderson, thank you.
Okay, now we need to find our asymptotes. Verticals are what make the denominator 0. We don't care about those now. So horizontal or slant describe what the function is doing as the limit as x goes to infinity. So if I say the limit as x goes to positive or negative infinity of that, that's going to equal, you might have to rewrite it, sorry. The limit is this one as we go to positive or negative infinity. Okay. So as x gets really, really, really big, or really, really, really small, let's just look at this. Okay. Now I'm going to shortcut this.
Why don't we just look at that?
You'll see in a sec. We'll do it the proper way. So you'd multiply top and bottom by 1 over x, right? So we go, I'm looking at that. It's the limit as we go to infinity of 2 over x minus 1. Well, I multiply top and bottom by 1 over x. So I get 2 over x over 1 minus 1 over x. Okay. What happens to the top as we go to infinity? That goes to 0. What happens to the bottom as we go to infinity? 1, because that goes to 0. What's 0 divided by 1? 0. So this whole thing disappears, right? So this thing goes to 0. What am I left with? That is your slant asymptote. Because as you punch in bigger and bigger numbers, what you're adding to this is essentially zero. It gets smaller and smaller and smaller and smaller. So your function gets closer and closer to this line, x plus 1. And I'll show you what it looks like on a graph. So if we go back to Desmos here, I'll put it back up in a sec. So if you punch in, I don't know, what was the function again?
The original one?
Yeah, x squared plus 1.
Over x minus 1.
So this is your function. You're like, well, that doesn't look like anything. But what did we say our slant asymptote was?
X plus 1.
X plus 1. So if I plug in x plus 1 in here, whoa,
Oh, nice.
not x equals 1. X. Here we go. You can see.
How do you find that? Like x plus 2, like how do you know?
What do you mean? How do I know?
Oh, never mind. It just starts crossing through at 1 and then.
Yeah, it moves it up or down. As the function, as we go to positive infinity, the function gets closer and closer to this line. And if you go to negative infinity, it gets closer and closer to that line. So that's a slant asymptote.
And so our critical points there are what? Plus and minus.
Critical points are the max and min. We're going to do a question that involves a slant asymptote, a whole curves catching question.
It's basically like the reason it's not is like the plus 1 just moves 1 point up 1, and then the next value is negative 1. Like what the x-intercept is negative 1, the y-intercept is 1, so you have your slope there.
Yeah.
Okay.
Yeah.
And then that's
The slope is 1 over 1.
Yeah.
1. And the y-intercept is 1. It's 1. Yeah, up 1 over 1. Up 1 over 1.
And then these asymptotes will always continue with the exact same slope.
The slant asymptote, yes. Now,
I'm sure there's probably
all you really need to remember is when you do the division. Now, I don't know what he's going to expect you to show. If you're in, sorry. It always does. It always does, because that's the reason we rewrite it as q plus r over d, right?
So you could just look at that and then know that x plus 1 is the.
That's the thing. So we'll do another one. The r over d part goes to 0. That's the whole reason we rewrite it this way.
basically our quotient is always going to
Your
be
quotient is the slant asymptote.
Okay, well, that's nice.
So let's do one more just for practice. All right. The limit as x goes to positive or negative infinity of x plus 2. I don't know. Do you want to try this one on your own?
Yeah.
Okay, so you got to do synthetic division. Go. I'll freeze it, and then I'll put my answer up.
Does it matter if you do negative infinity part as well, or you just do the same?
No, it doesn't matter. Because if you look here, if I put negative infinity into this, Riley, that's still going to be 0. And that's going to be 0, so you're left with 1 here. Yeah. Yeah.
They're also like at x, so there's going to be 1 for x squared minus x, and then there's coefficient for x are 0 as well.
Sorry, say that again. What?
For that question, like the question that we're about to do,
Yeah.
is there a coefficient for x to the power of 0 as well that we have to?
No, because it goes down in order, right? 2, 1, 0.
Oh, that is x to the power of 0.
Yeah, yeah.
Divisor's negative 2, right?
The divisor is negative 2. The a value is negative 2, correct?
And then you drop down to the x squared to 1, and then you just drop that 1 down.
Yeah.
By your divisor.
Do you want us to write the q plus r over d thing? Or do you
Write it as q plus r over d, and then say this will go to 0. And remember he said yesterday you can give an explanation of why?
Okay, actually solve it?
Yeah. Actually solve it, please.
But what do you do with your quotient if you have 1 minus? confused is how you, like in the first one, you said our quotient was x plus 1. What would our quotient be here if you're left with?
Well, you're dividing a quadratic, degree 2, by a linear, degree 1. So you should end up with a linear, degree 1.
Yeah.
So it's just going to be x, whatever your number. Yeah.
Because I have 1 and then a minus 3, so x minus 3.
Yeah. Is that what people got?
You didn't give me enough time.
Sorry.
Oh wait, it was just that.
Yes.
Oh.
So you got x minus 3 plus 7 over x plus 2? Okay, what part goes to 0? If I say the limit as x goes to
You have to show that.
you should write, see, that's, I don't know what he's going to expect for my class. If you wrote this, okay, the pink part with the limit, and then you went like this, that goes to 0. Because you know that's going to go to 0 because it's a constant divided by a really big number plus a little constant, who cares, right? So it's 7 divided by infinity, that whole thing goes to 0, and you're just left with that, x minus 3. So the slant asymptote is y is equal to x minus 3. You know why they're called slant asymptotes? Because they slant. They're all linear lines. Because the difference in the degrees is 1. So it's not 45. It's always a linear line.
Oh, because it's going to be 1
Right?
and then your other number.
You could have a coefficient there that's not.
So that's why
Whatever.
it has to be 1 bigger. Because
It has to be 1 bigger. I'm going to show you what it looks like if it's 2 or 3 or 4 or 5 bigger. Okay? You don't need to know that for this class, but it's kind of cool to think about it.
Look at like a parabola.
So, yeah.
Yeah.
So this one is just to show you. Come on. And we're not just making stuff up here.
Well,
I know.
it all kind of is. But
What did I write? X squared minus x plus
1. X plus 1 divided by x plus 2.
x squared minus x plus 1 divided by x minus 2.
X plus 2.
There. So again, you can see they all have this sort of general shape. Get off the graph. So then if I plug in my, what's it, x minus 2?
X minus 2.
There you go. There you go.
So how do you know to draw it like that?
Well, we're gonna do a curve sketching one of these, and you're gonna see that you have to do concavity, the max mins, all that kind of stuff.
Oh, no.
So we're gonna do that. Okay, does that make sense?
Yeah.
Now that's if it's degree 1. You don't have to know anything beyond that. But just because it's kind of cool. What if the difference is degree 2? So for example, what if you have this function? Minus x. Don't write any of this down because you will not get tested on it. So 1 minus x to the power of 3 over x, okay? What's the difference in the degree between the numerator and the denominator? It's 2, right? What does an x to the power of 2, a quadratic function, look like? It's a parabola. If I plug in this case, it'll be a negative x squared. You can see, as you go to positive or negative infinity, the function starts to become negative x squared, the parabola.
What's with that other line, though?
Oh, this is just part of the original graph. But that's as we go to 0. As x gets bigger, the blue graph gets closer to the graph of negative x squared. What if it's a third degree difference?
Whatever third degrees do.
Exactly.
POI.
So, no. So watch. If I do x to the power of 4 plus 1,
No, but also.
all right, bracket over x, I don't know, plus 1.
Oh.
Let's just do x. Okay, there's our graph, okay? There's our graph. Now, you're like, what's going on here? But I know that the difference between the numerator and the denominator is 3. So if I plug in x to the power of 3, that is your asymptote. This is a x to the power of 3 graph. And you can see as you get bigger, the purple function, the original, approaches that.
So you
I thought I'd actually be
find
interested
your
in
critical
lines.
points, you see it's concave up or down, and then how would you know like where to draw that in line with x to the power 3?
Well, we're gonna show you that.
That would be an F double prime, wouldn't it?
Yeah. Yeah. Well, you're looking at concavity. It's concave
I
up
can do all the
everywhere.
math, but when it starts to like draw shapes, that's my
Yeah, we're gonna do one in a sec here. Okay. So it doesn't matter what the degree difference is. What if I change this to 17?
Sure.
I don't know what that's gonna look like, but
Oh,
okay,
wow.
that's interesting. Okay, so what should I put in the bottom one?
16.
There you go.
Yeah, that's good.
They line up. All right. So all you really have to do, and it's basically, you could do synthetic division on this. You're gonna have 15 placeholders, right? 15. 15
It's always
placeholders.
one less.
Right, because there's two numbers there, right? So you'd have all those placeholders, but you can see as you go out here, the graphs just get closer to whatever the difference is. All right. You only have to know slant asymptotes in this class. All right. So let's do a practice one.